Good morning, good afternoon, or good evening, depending on where you are and whether you're watching live or archived. And welcome to episode number 101 of the Nautel Transmission Talk Tuesdays. I'm your host, Jeff Welton, and we're going to do it a little different today. And I'll talk about that in a minute, but let's first do the housekeeping stuff. So, mandatory housekeeping stuff for anybody who hasn't been with us for a bit. Of course, go to webinar, change their interface, Zoomified it if you will. Same basic rules. You've got the ability to ask questions. You can type them in. I do have the question window open on my lower monitor. So if you see me looking down at my toes, that's really what I'm looking at. And look, private messages already. This is not good. That's Ed up there. Ed's telling me looks good, sounds good. By the way, shout out to Mr. Disembodied Voice. Edward Sylvester is the one back in the background making sure that I don't run too far off the rails. So absolutely put in the questions. You've also got the ability to unmute yourself and make yourself part of the conversation. That may require dispensation on my end. We'll find out as we go. But that was what I was getting at. You'll notice I didn't have any special guest this show. For this topic, almost everybody in the room has got A, opinions, and B, a whole lot of education on the topic. So I want to make this as interactive as we can. Nobody should have to listen to me talk uninterrupted for an hour. So let's get involved here. So our topic, air handling. And I'm going to caveat, this is taken, we did this topic about 4 or 5 years ago. And I looked at it later and said, there's not a lot of discussion about liquid cooling in there. So we'll talk to that a little bit as well. Now, understand, again, I've made a career out of finding people smarter than me to talk about stuff. We don't build a liquid cooled transmitter. So for that, I'm going to rely on y'all to put some stuff in. Marco's already throwing some shade at me in the questions with when have we ever stopped at an hour? I think we've had like 3, maybe 4 that we managed to keep it down to an hour. So anybody who does have a hard top of the hour cutoff, understand the recording will be posted, so you do have access to it. Going back to the maintenance slide real quick. Remember that if you are an SBE member and you're keeping track of your certification points for recertification, that this webinar will qualify for half of a credit under Schedule I. So make sure that whatever spreadsheet, notepad, whatever you keep track of that on, that you jot this down. All right, that was all I had there. So moving forward, the topic is air handling, air conditioning, cooling in general. And it's kind of been a relevant topic. Oh, Shane has thoughts. What a surprise. So yeah, we're going to have some fun with it. But it's one of those, I mean, for the first time, I've lived in this part, Eastern Canada of the world for better part of my life anyway, although I spent a lot of time on stateside as well. And for the first time ever, I'm actually looking at installing heat pumps for the house. It's getting a little warmer. And doesn't hurt that the wife likes to be more comfortable, and I'm a little more of a fan of roll up your sleeves and suck it up. But anyway, so here's some of the data that, and I've had people ask me for this before. I've brought it up in other discussions where if you look at fans or electrolytic capacitors, as a rule, they're spec'd at a specific temperature with a specific lifespan. And every 10 degrees Celsius or 18 degrees Fahrenheit that you decrease that temperature, you increase the lifespan. Now, for fans, it works out to be, for the one I was looking at the time, it was spec'd at was 5,000 hours for or 5 years, sorry, for a 40 degree Celsius, 104 Fahrenheit ambient. And if you decrease 10 Celsius, 18 Fahrenheit, so to 30 Celsius, 86 Fahrenheit, then that lifespan doubled to about 10 years. If you decrease another 10 degrees or 18 Fahrenheit to 20 or 68 Fahrenheit, it doubled again to about 20 years. And this is looking at a specific MOSFET MTBF, specified failure rate. And same situation, you can see that the MTBF roughly cut or gets roughly doubles for every 10 degrees, or for the 10 degrees for this chart at least. So even on MOSFETs, running them cooler makes them live longer. Okay, now how do we get cooler? That is the topic of this entire session. And one of the things that brought it on was an article in Radio World a while ago that John Marcon had written. He wrote it originally in, I think, 2018, and I've got it tagged in the references at the end. But talking about cooling, and it's a big deal, because when you call the transmitter manufacturer, you call me and say, how much air conditioning do I need? The number I give you will be exactly what is required to cool the heat or remove the heat produced by the transmitter. I'm not looking at building heat. I'm not looking at anything else in the building, or convection heat from the sun or any of that. So there's a lot more to it than just, how much heat does the transmitter make? How much heat the transmitter make is an important part of it, but it's not all of it by any stretch. All right. So first things first, you got to know where you are. Now, where I am used to be considered very cold and now is in the cold band. It will vary a lot. And of course, there are going to be little regional microclimates. If you're in Colorado, depending on your altitude, you might vary between one or the other, as an example. I've been in Colorado Springs when it was 70, 75 degrees, and up in the top of Pikes Peak, it was snowing. So very much there are going to be some variables in the factor, but as a general guideline, understand where you are. I mean, some people are like, well, air conditioning is expensive. And, in the part of the world where I live, for example, our air conditioning season is about 3 months long, give or take. If I saw Jake on the attendee list over in North Dakota, and over in North Dakota, I mean, Jake, Fargo, Bismarck, you got what, probably about a 4, maybe 5 month air conditioning season. Other than that, open a window, and not talking about house, but you can do that in a transmitter building to some extent, and we'll talk about the options there. So that's the kind of thing we want to look at. Now, if you are going to quote unquote open a window, make sure you're filtering it, because that gets expensive too. Running dirt through everything. I always told people, and there, Chuck's saying, yes, 7 months in Phoenix for houses and pretty much all the time for transmitters, because again, you jump kicking out a lot more heat. But that is something that we'll talk to a little bit, because there are options where you can, possibly cycle some outside air. Before I get raining or running too hard on this, Shane, do you happen to have a microphone today? I see you typing, so I'm gonna put you on the spot. Let's take a peek here and find you. Enable me, he says. All right. Enable, I do. There, it does require special position. Okay, Shane, you should be live.
Oh boy, Jeff's giving me a microphone. That's dangerous. So,
So, so
go ahead.
you've got the unique position of growing up in Minnesota, living a good chunk of time in Wyoming, and now being in California. You've experienced 3 different temperature zones according to this map.
I very much have, and what I've seen in terms of sites and how they handle things at those sites, pretty radically different between them. Minnesota, of course, you do have the ability to cool with outside air for most of the year, although some of their summers are getting a little hotter now. But you don't
So,
necessarily want to do that in the middle of the winter, because Alex Hartman has discovered what happens when I think he discovered the lower thermal limit of a Nautel transmitter.
so Alex has discovered both thermal limits of a Nautel transmitter in the same building.
The same building.
He's had the ambient in the room up to 160 Fahrenheit, and he was the one that discovered we didn't, in the original software, didn't put the placeholder in for negative numbers. So when you went below 0, it rolled over and started at the top again,
Yep.
and it gave him a high temperature alarm at minus 30.
That was entertaining.
So
All right.
absolutely. But having said that, with a controlled system, I mean, properly louvered and installed system, and it's cheaper to
Right.
install fans and louvers than it is to install an air conditioner and maintain.
Absolutely. Absolutely. But yeah, it is important to note that a lot of these systems that are at some of these sites were designed back when tube transmitters were more the style, and more in vogue. And some of them, some sites still do use them, to be fair.
Hmm.
But those were designed so that you could recycle the heat from those transmitters into the room during the winter time, right?
Yep.
It's a lot harder to do that with solid state transmitters, although some of them do run hotter than others. No throwing names here, but
No, it
anyway,
doesn't matter. I mean, and it depends on the operating mode. If you're
it
running
does.
HD only transmitter, you're going to be 30 to 35 efficient. So yeah, you're dumping 2/3 of your heat into the room,
Or if you've still
or
got,
into the exhaust system,
yeah, if you've still got one of the old high level combined systems, and I'm sure there might be one or two of those still out there.
or 20 or 30 or more. Yep.
Right, right. Where you're
Um,
dumping the dummy load heat into the room. So,
Right. By the same token, a liquid cooled system can only cool or heat whatever. It can only cool to ambient.
hmm
So if it's 110 degrees outside, that is your cool temperature. And in that case, depending on your transmitter, you may need to take additional steps there as well.
yep. Well, the other zone that I lived in was the mountainous zone, Wyoming. Again, very some similarities there to Minnesota in that regard, in terms of the cold and being able to reuse and recycle some of that. But there, you also have the issue of, in a lot of places, kind of desert, arid type dust in your environments. I
Right.
mean, Minnesota, you've got, in the mountain and some of the mountains, you even had, you had cottonwoods, of course, as well. So that's another challenge.
Well,
Uh,
and that's a big deal. I mean, I went through Minnesota, Wisconsin, and Michigan one June and stopped at three different sites. And every site, all the air filters were a quarter inch thick with cottonwood fuzz.
yeah, exactly.
So,
Yeah.
100% and that's why I titled this one "Know Your Environment." I mean, where I live, we don't get cottonwood. We do get dandelion fuzz, but it's typically much more isolated depending on where you are.
Well, what really frustrated me is when I would come into sites and I would see that they had little or no filtering on the air inlet at all. And that is the worst possible environment that you could put your gear in. Outside air is dirty. I
Yep.
don't care where you are. Outside air is dirty.
Right.
So I in my current environment now, I'm actually sitting in a building here. It's the 680 KNBR site in Redwood Shores, just right off of it's in a salt marsh, right off of the coast.
Hmm.
And I'm sitting here, like literally about a couple rooms away. There's a giant fan or blower sucking in air from the outside, because this site had traditionally been cooled with nothing but outside air as well. But the difference is it was actually really well engineered. The filters are multi-stage filters with kind of the big bags that hang off of them and stuff like
Hmm.
that. And it's so the outside air really doesn't pose an issue in terms of cooling this space. And it's rare that it sees above 80s here, even in the summertime,
Right.
being right on the coast. So that works fairly well. And then we did, in fact, add some supplemental couple of split units to cool a space now where there's more tech equipment than there ever used to be.
Right.
So,
By the way,
anyway,
folks, while I'm thinking about it, and of course, Shane hit me in the comment section or in the questions, but there is a hand raising icon there as well on your control bars. So if you want to, throw some 2 cents in, then definitely hit that. I am paying attention to it. All right. And I'm sort of paying attention. I put this building science link up here, and I wanted to leave it up while we talked so folks had a chance to catch it. And remember that this will be archived. We'll get you a PDF copy as well. But that building science site has a pile of articles on this topic, not just this one and this one, but 100%, you know understand the building you're in. Now, Shane, you got a really good point too with the salt marsh, because the prevailing winds typically blow west to east. The west coast is also much more susceptible to salt air corrosion in open ventilated buildings versus closed sealed air conditioned.
right, and that's an excellent point. The one thing that outside that bringing in outside air doesn't take into consideration is the humidity. And again, I see that in the south. I see that here on the coast. Heck, you see it pretty much everywhere. Everywhere, unless you're in the middle of the desert. That's the one thing I didn't have an issue with in the mountainous, and desert areas was
Hmm.
was humidity. But almost everywhere else, yeah, you're going to be dealing with humidity. And yeah, out here on the coast, especially, you got salt in that air. And
Yep.
yes, it can be really hard on your stuff.
Right. And I mean, here on the East Coast as well, if you're right on the coast, I've got, as an example, my smoker outside. It's undercover in the carport, never been rained on, never been wet, but any exposed steel is starting to rust after 4 years because there's a lot of salt in the air and you get a lot of oxidation. So, know your environment, know your building. Those are, I guess, your critical starting points. And I had the example not too long ago. I was talking to a guy in northern Wisconsin, and we were talking about cooling. And I said, for the price of a 2-ton air conditioner, you could put a really good double filtered multi-stage clean room as an air intake, put big honking intake fans on it, throw a couple of exhaust fans, positively pressurize the building to keep all the dust and fluff out. And right off the bat, for 8, 9 months of the year, you're covered with that. And that's just some periodic fan work. So, first things first, you got to figure out how much heat you're generating. Now, transmitters, it's pretty easy. If you know the efficiency, you know how much power you're consuming. Whatever power you're consuming that's not going up the antenna, that's heat, period. Easy math. And then from there, it's just converting it to whatever form, whether you want BTU or per hour, whether you want tons of air conditioning, that again, easy math. And I say easy math, the big caveat, a lot of manufacturers, less now, but more in the older days, used to spec DC efficiency, plate efficiency. So they weren't allowing for any power supply losses or anything of that nature. And I mean, I've seen Energyonics transmitters as an example, and not to pick on Bernie specifically, but showing a 80% efficiency. Um, I've never measured one with anything near 80% AC efficiency, 50 on a good day. So 100% be absolutely certain that the number you're looking at is the out of the wall. And a fast way to measure it's just grab a clamp on current meter, slap it onto the wires coming from the panel, measure the voltage, and do the math. So, E equals I times R. That's never going to change. And it's the rule we live by. Shane, you do this on a fairly regular, well, not too much. I mean, once you've installed it, you don't have to mess with it daily, but you do this math fairly regularly.
Oh yeah, yeah, all the time. Um, when you're putting a new transmitter, you got to take into account what you're actually going to draw from the wall. I mean, especially if you're putting in like a generator or something to back your site up, you want to make sure that you're able to actually handle that load. And yeah, a lot of people forget about their cooling when they do that, especially if they're using mechanical cooling instead of just fresh air cooling.
Right. And I mean, a 2000 CFM blower is going to draw some current. It may not be 20 or 30 or 40 amps, but it's going to be enough amps that it should be figured into the math.
Yeah.
So, So I mentioned positive pressure earlier, and basically positive pressure means you pull more filtered air into the building than you're exhausting out of it. And that way you keep the positive pressure in the building so that every nook, crack, crevice is leaking air out, not sucking air in. I run into so many sites that they'll have a transmitter, and it goes back to the old tube days where you had a chimney coming off of the plate section of the transmitter, and one big honking exhaust fan sucking the air out and pulling dust and crud in through every crack and crevice. And Shane, oh shoot, if I had known you were going to be here, I would have put up the picture with the bathroom fan cooling the XL12. But
Oh, that one, that poor transmitter.
so Shane had a site where the transmitter was sitting there. There was like a little red bathroom fan that was the ventilation for a big steel building.
To be fair, that was a tenant at a site that I was a contractor for. It wasn't actually mine, but I just had to shake my head when I saw that one.
Yeah. Now, Roland's asking a good question in here, and I'm going to throw this to you. Let's see. There we go. How do you keep the salt air from getting in? Worked on a transmitter at Sutro with 15 kilovolts of E plus, where the control board got arc tracking due to the salty white moisture, and yeah, the air filter didn't help to keep the moisture out there. And in that case, you almost do need a clean air room where you can treat the humidity as well. Thoughts on that, Shay?
Yeah, exactly. I think the only way you really truly get around that is with some kind of mechanical cooling where you can deal with the humidity. It's surprising. Sutro is usually pretty good about that. But out here at the 680 site, I don't notice a whole lot in terms of that with the filtering that's on there. But yeah, it's definitely an issue. It's definitely a consideration in these coastal areas.
Yeah. And I'd say here on the East Coast, I mean, a little less so because our prevailing winds are mostly offshore, not onshore. But depending on which side of the province you're on, your cove could have an onshore wind. So, and it does tend to vary a couple of times a day too. So absolutely pay attention to airflow direction as well. And this is something I'm just going to click through all the don't do this and do this stuff. But I run into so many sites where the air is blasting past the back of the transmitter at 100 miles an hour. And all it's doing is creating a negative pressure zone in the transmitter itself. So it's actually pulling air away from the transmitter, not through it. And Shane, you become my de facto guest today, so everybody else is being
Oh
shy, and
boy,
you
you're
got
in
you
trouble
got her
now.
covered. So yeah, I mean, this is a really big deal. Look at and this every time you replace a transmitter, that's something you need to consider. Like I know that the fax transmitter or the GX I know takes the air in the front out the back. I think the fax does too. Speaking of Gates Air, our VX transmitters pull air in the front and out the back. The GV and NV light pull air in the rear and in the front and out the top. And every manufacturer and even different models within the same manufacturer may be different. So you do have to pay attention to that.
Yeah, a couple comments on that. I know that you've touched on this as well. One common thing you see is like these package units, these barred package units that hang off the wall, right? Uh, they, for most of these applications, have the inlet and outlet in the wrong places. You can
Right.
get with them reversed. In fact, I've seen that. I've also seen traditional installs where the inlet and outlet. I think actually at one point I sent you a picture of a site with 4 air handlers. Basically, they were upside down. They were reversed
Hmm.
for that very reason, to give cool air to the right side of the transmitter and to suck the hot air away from the other side.
Yeah, and there was one manufacturer, and I can't remember who, might have been Marvair, but I'm just guessing. I have no idea for sure. So if somebody does remember, throw it in the comments. But a lot of the cell sites had them, and they were specifically designed so they could be installed upside down to put the cool air at the bottom and the hot air return at the top. So, if anybody knows who that is, throw it in the questions and we'll bring it up in the conversation. But yeah, the challenge is that those units were designed for office and home use. So they shoot the cool air out at ceiling level. Of course, cool air sinks, hot air rises, and the cool air would sink down, nobody would get a breeze in their face, and you could get some stuff. Everything was cool and comfortable. The problem is that transmitters shoot the warm air out the top, or it just rises depending where it comes out. So you really need the warm air return to be at the at ceiling level. Um, I see Michael's got his hand up, Michael Glazer. So, Mike, I've got you unmuted. Feel free to chime in if you've got a microphone. And I see William said that it was Marvair that gave the ability to do the upside down install. He thinks so. We got two on that concept or two on that thought process.
Well, and when you think about it, it does make sense. The traditional orientation makes sense for humans in a room. I mean, hot air does rise and cool air does sink, but yeah,
Yeah.
you want that. In most office spaces, yeah, you want the humans comfortable. But I've always heard if your humans are comfortable, then your gear is going to be comfortable. But that's not necessarily true if your air is not flowing
No.
the right direction.
So, and we'll see some pictures. And I say, Michael, I've got you unmuted. So if you have a working mic, you should be able to unmute yourself and become just butt in when you get there, and we'll carry on. But yeah, I mean, I've run into a lot of situations where the room was at a balmy or a nice cool 60, 65 degrees, and the transmitter was overheating. You can have all the cool air in the world, but if you don't push it through the equipment, you're not doing yourself or the equipment any favors. There we go. So bringing up liquid, and because a lot of folks are like, you guys don't pay any attention to liquid cooling, and that's 100% not the case. A matter of fact, and this was done, I want to say about 20 years ago, might have been 15. It's been a day or two, but we did an actual matrix on one versus the other. And now I'm going to quantify that a little. So this is what it looked like back then. Some of those numbers have changed. One of the things they had the maintenance, they had the advantage to air because at the time, the state of the art for liquid cooling required regular recycling of the glycol. Taking it out, filtering it, putting it back. These days, that's not necessarily the case. Rhodey uses a proprietary glycol mix. Gates Air uses basically Prestone, if I remember right. So mileage will vary from one to another to another. At the time, there was a lot more familiarity with air cooling, of course, in radio because we weren't doing a whole pile of liquid. So, that'll vary a lot. Now, Elijah mentions in the questions, I'm just going to, so yeah, 100%, each of them has their own challenges. Like I said earlier, liquid cooling, you can't cool below ambient air temperature. So on a 110-degree day, that can be an issue. You're almost to the transmitter trip point, depending on your transmitter maker. So, pay attention to the details. Always look at the details. Air conditioners, Shane, I'm guessing that it's a safe bet that air conditioning maintenance is probably your biggest ongoing maintenance cost outside of maybe generators.
It is. Those are, in fact, the top two.
It's
Yeah,
almost like I'd had this conversation before.
right. Right. And yeah, it can be challenging. I mean, we have a contract with a company that does go and do the PMs on ours, and if something does fail, we call them up and say, "Hey, fix it," and they take care of it. Yeah, but it's super important. As important as having cooling in the first place is having some strategy for maintaining it is equally important.
Well, and that's accurate, not just for air conditioners, for everything.
Absolutely.
I mean, if current flows through it, current will eventually stop flowing through it. And a lot of that, if it's got moving parts like an air conditioner or a generator or the fans in a transmitter or the pump in a liquid cooled, I mean, all that stuff you can assume is going to suffer some level of attrition at some point. How cool you keep it, how much back pressure it deals with in the case of pumps and fans, that will also contribute significantly to lifespan. So 100% do a full site assessment. And this is actually a discussion that somebody brought this up recently. I was talking specifically about auditing sites, and I was looking more in the IT domain. How many ISDN lines are you paying for that haven't been used in 10 years? But do a full blown energy slash maintenance audit of your facilities as well. Every piece of equipment should have a maintenance schedule of some sort, even if it's as simple as swap the air filters out every 6 months in the winter and 2 months or 2 weeks in the summer if you're in cottonwood country. So, Shane, how do you work with that?
As far as like a regular schedule, or as far as like the energy audit. I mean, it's an ongoing process because things can and do change on a regular basis. So, I mean, if you've got a site where maybe your transmitter's been updated, but you never really went back and looked at what the cooling requirements were or what the energy requirements were, it's a good time to maybe do that if you haven't done it in a while. So,
Mhm. And it's something that can vary. Again, if you replace a transmitter, your tube rig may have required a little more TLC than the newer one.
well,
Maybe vice versa, depending again on brand.
I'll give you a prime example again here at the 680 site. We about a year or so ago made some changes in this market and split our studios and our TOC. So now our TOC, our rack room, basically lives out here at the 680 site. Well, of course,
Hmm.
the requirements for modern IT equipment are much different from those of a transmitter. I mean, that DX50 and that
Uh,
3DX50, well, depending on the transmitter, okay?
so now, in fairness, the requirements for modern IT equipment should be the
They're
requirements
very
for
similar.
any solid state
Yeah, that
transmitter.
should
But
be your standard. But in the past, traditionally, the thought process has been, oh, the transmitter can live in a little warmer environment. It's not a big deal.
right.
But you and I both know, of course, keep it cooler, it'll last longer. Anyway, but yeah, that 3DX and that DX50 will sit there and run in a room that's, quite a bit warmer than, say, a modern data center would be.
Right.
But yeah, you start installing racks full of computers. And in our case, what we did was like I said earlier, we ended up installing a couple of split units to cool that space for
Hmm.
for the extra cooling for those computers. And yeah, so it's
Now,
stuff like that you have to pay attention to.
right. Something else that I've just come out or come across fairly recently that's kind of interesting. I was going to say kind of cool, and yeah, okay, that too. Have you seen any of the rack mount air conditioners designed for servers?
Yes.
So you just basically throw it in the bottom of the rack and or in the top, whichever. I'm not sure. I don't remember, but it shoves the air, just basically cools the rack as a self-contained unit.
Yeah, yeah. They also make these cool things that go between the racks called cracks, where basically the cooling is in your rack row.
Hmm.
But I'll give you one caution about those. We recently had an issue as well where the building was providing the water loop, the cooled water loop, the chilled water loop for those cracks in the tech room.
Hmm.
Well, guess what failed?
Yeah.
It
Well,
wasn't our fault. It was the building supply of chilled water to those units.
right.
So now we ended up rolling in some portable coolers
Yeah.
to that
And
space.
these ones work on a different theory. They use heat recovery from ambient air to chill the coolant in a closed loop system inside the device.
Little miniature heat exchangers, basically.
Essentially.
Yeah.
So, I've seen them where they had heat ducts that remove the excess heat out of the area and then replenish it with room air. I've seen other ones where it's a totally closed, almost like a laptop system, where they just run the fans through that little cooling unit and then use it to create the cool air for the rest of the devices. So, there's some interesting options out there. Elijah in the comments has asked on an NV15 with 10.8 out, would a 10 BTU, and I'm guessing, Elijah, that's 10,000 BTU, split level air conditioner behind the transmitter work. So for that, we'll have to do some math, but let's flip back to our heat load page. Apologies for all, I should have just froze all those graphics before I did this. So if we look at, and we'll use 10,000 as an easy number. So on an NV15, your average overall efficiency is 72%. I'm going to use 70 because, again, I'm a big fan of easy math. So we'll take, let's use 11,000 because we'll go worst case for this. So close all, there we go. I've got two phones, no waiting, which means I've also got two calculators. I just had to find them. There we go. So we take 11,000, we'll divide that by zero point 0.7, gives us a nominal power consumption of 15,714. We'll subtract the power going up the antenna to get 4,700. Now that 4,700 watts of waste heat times 3.413 to convert to BTU per hour gives us 16,000 BTU per hour. So if that was a 10,000 BTU AC, then no, it wouldn't be big enough. You'd probably want closer to, and again, remember I high sided, but you'd want at least 15,000. And once again, that's only cooling the heat from the transmitter. That's not covering ambient heat on the building. And in Elijah's case, I know that site is down in the Delta, and it can get pretty toasty there in the summer. So absolutely pay attention to that sort of thing.
Jeff, I'll pose this question to you since I know
Yeah.
we've had discussions about this. Can you have too much cooling at a site?
So the answer is sort of, kind of, it depends. And I see Elijah's got his hand up, so let's bring Elijah right in here, and we'll do this because Elijah's one of my customers, and I say, if you ever want the best catfish ever, just hook up with Elijah, and he'll there's a place down not too far from his site that is just amazing. Uh, Elijah, I've got you unmuted, so jump on in if you got a microphone.
Can you hear me?
Sure can, loud and clear, sir.
Yes, you've been to our site twice. It's a concrete block building.
Yep.
And I have two 24 BTU window units in the concrete block building. You've seen that.
Okay, so
And
that'd be 24,000 BTU.
Yeah, that's it.
Yes, sir.
Yeah,
So,
and
so basically 2-ton units.
yeah, so one of them comes on if the other one goes off. One runs, and if something failed on one, the other one is set to kick in.
Yes, sir.
But for some reason, when I put in the brand new Nautel 15, the electric bill shot up. And so we're trying to figure if it's because of the air conditioning. And that's why I've been wondering if I got a smaller BTU unit and ran it directly, like a split level, and ran it directly into the back of the Nautel right where the filter is.
Mm-hmm.
Would that help? Would that help? Maybe even with a 15 BTU, would that cut down on the electric bill? Because my wife is upset about that.
Well, and if it's more efficient air conditioner, then certainly it's going to draw less power. And I mean, I know what you replaced there. So assuming that your transmitter power stayed the same, the power bill should definitely not have gone up. Now, I'm going to quantify that because I know I was working with another fella not too terribly far from you, Mr. Reuben Hughes. And
Yes.
you remember Reuben.
Yeah,
But Ruben was upset, and it turned out that his old transmitter, well, number one, his air conditioner was switched off, and number two, the old transmitter was only running half power. So when we put the new one in at full power and turned the AC on, of course, the power bill went up, not down. But yeah, I'll tell you what, I'm going to be out that neck of the woods again. I'm going down to do. I'll be at the Arkansas show again this year. They're bringing me back into your territory.
wow, all right, all
So,
right.
So why don't we make plans? It'll have to be right before the Arkansas show because right after that I've got to be up. I think I've got to be in Wisconsin right after that.
Yeah, the
But
Arkansas show is in Pine Bluff. What
yeah,
day would that be when you get in this area?
I'll have to look. But let's go offline and we'll have that conversation and get her sorted out.
Okay, I've been trying to call you. Have you changed your cell number?
It's the same. You keep hollering, and I'll check the voicemail if you're leaving messages. If you're not leaving a message, it probably goes to go voicemail jail.
Yeah, okay, I need
So
to get some filters, and I can't buy the type of filters that go in there at Walmart.
I found a company that'll do that for you, so I'll hook you. Tell you what, I'll send you an email and give you a link where you can get that.
Okay, I appreciate it.
All right, very good. Thank you,
All right,
Elijah.
when you come here, I'll treat you to some catfish again.
Oh, you know that's the only reason I come down, right? It's got nothing to do with hanging with y'all. All right, I'll let you go. So Shane, back on the discussion, we were talking a little bit about air. Well, and Bert's got in here the preferred airflow path, and that comes back to what I was saying. Like he asked about the NV. Well, on the older NVs, it was rear only. On some of the newer NVs, if you've got a grill in the front, if there's an airflow intake, then you need airflow going in there.
It's also worth noting that we talked about liquid cooling earlier, and at least one of the liquid cooled designs has the power supplies separate that are not part of the liquid cooling loop. They're still air cooled, so you still need to take that into account as well if that's what if that's The
Well,
displacement is.
and above and beyond that, and nothing against the manufacturer, but one of the manufacturer reps at one point, and not the same company, was saying, if you put in our liquid cooled transmitter, you don't need any air conditioning at all in the building. And that is also not exactly
No,
correct, because you still got controllers that are
exactly.
basically computers. And as we said with the server, those things don't like to get hot. And William mentions and the exciters and the HD gear, et cetera. Right.
Exactly. Yep. Yep.
Not to mention, if it's 100 degrees outside, I'm pretty sure your engineer's not going to be too happy at the building's 100 and something degrees inside. So, I always make the joke, I want to keep the equipment cool and I don't care about the engineer, but that's not totally the case. All
Nope.
right, let's flip back to where we were here and just carry on a little. Um, so here's a perfect example of airflow direction. And I didn't notice if Bob or Matt were in the audience today, but they're going to just roll their eyes and go, "Man, you got to stop using that picture." Um, so this was a site. Speaking of Arkansas, this is northern Arkansas. The room now, that silver flex hose is the air conditioner, cool air out. The little square duct below it is the warm air return. Okay, which is a pretty, again, sort of the same layout you'd have with a Bard or an upside up Marvair, that sort of thing. Cool air goes out the top, settles down. Room 60, 65 degrees. On the left picture, that light gray cabinet at the rear of the picture, the one up against the cinder block wall, is the transmitter with the intake. The cool air intake is the rear, the left, and the exhaust for us, of course, is out the top. So the room was in the 60s, 65 degrees maybe. It was almost sweater weather in that room, and the transmitter was overheating because the cool air return or the warm air return is busy sucking away from the transmitter intake, running it severely starved with a lot of back pressure, and it's just cooking. So we ended up moving that cool air outflow so that it dumped the air down behind the transmitter into the intake and then ducted the exhaust. They did, the two wall units you see installed in the right-hand picture were added as backup. And the last I checked, except for when the main system was down for maintenance, they'd never been needed. But by doing this, we raised the room temperature 5 or 10 degrees and dropped the transmitter temperature by 20 or 30, and made a huge difference in lifespan. That and some grounding for some other issues. But yeah, I mean, you learn, of course, by doing this stuff. But that's a probably one of the best examples I've run into with airflow direction. So we talked about clean air room, and here is Jeff's very quick Microsoft Paint version of a clean air room. Shane, thoughts?
Yeah, absolutely. I'll have to send you a picture actually of what the system out here looks like. But yeah, basically you want that kind of pre-filter area and then the secondary filter after that. And that will go a long way toward keeping the environment clean, especially if you make sure there's enough air volume, more air volume going in than going out.
Right. And in this picture, the light gray boxes near the top of each room are air filters. And that comes back to what you were saying. The multi-stage bag filters are really great at getting the fine particulate out. And then, so you could put those on the lower section going into the room and then use just a wall of like FAR 2020 pleated paper filters, 4-inch pleated paper filters on the building input to catch the cottonwood fluff, stuff like that. That way, during cottonwood season or pollen season, you only end up replacing the cheap air filters on a regular basis to catch all the crud in the air, and then use the bag filters to clean all the fine stuff.
Yep, that strategy works really well if you can find a way to do it.
Yeah. Now, Michael mentions if your source of AC is a move and cool, bringing air from the outside and cooling it and venting it towards the transmitter intake fans. So, absolutely. I mean, different options for different things, but that works out well. John has made a good comment about a water trap air filter room, and this is, I from
Oh,
the
yeah, I've heard of this.
from the name, I think I have an idea what you're talking about. John, aren't you supposed to be retired? I've got you enabled here, so absolutely open up the mic. But you're doing retirement wrong, man.
Oh, I'm listening to people with their problems and I remembering things how we fixed them back then.
So a water trap air filter room. I think I understand the concept, but explain it to me.
Well, this is for the backup cooling for our transmitter site, uh, but we had incoming like the if we had to go to the backup air system, um, the air would come in uh, lower down on the wall and get sucked up by the fans into a room that had well, it was actually the entryway doors were there too, but you'd
Mhm.
come into that room, then there would be air filters to go into the transmitter room, and then the other way out, the exhaust blowers would blow into another room, so that any water, if any rain blowing the other direction, would be trapped in that room. There would be floor drains in it,
Mhm.
and so you get cool air coming through, or cooler air coming through. This
Right.
but the biggest problem we had was if the air conditioner died, the backup system would come on. Once you repaired the air conditioning, you had to turn off the backup air conditioning system because it's bringing in warm South Texas air,
Mhm.
and the air conditioner can't keep up with it. Uh,
Sure.
but it's still cooler than the hot air from the transmitter, and you're keeping the water outside.
Mhm. And that comes back to what we were talking about earlier. In a clean air situation like what I've got drawn here, you almost need some sort of humidity control. And you made a good point in your comment in the questions that hurricanes add a lot of water to the air. And like where I live, for example, up here on the coast, it's pretty common for our nighttime humidity to be in the 80-90% range. You can almost squeeze it. Now during the day, as the it heats up, that'll drop usually, unless it's pouring rain. But you're absolutely correct. That is a cool idea. Let me get down here. I saw a couple more. Lewis had mentioned monitoring, and this is a really good point. Monitoring intake and exhaust temperature on the equipment, and he mentioned he generally sees about a 20-degree differential. And so for our gear, as a rule, and I mean, it'll vary a little from one model to another, but as a rule, the experience has shown that if you're pumping enough cool air through, you're going to see about a 10-degree heat rise through the transmitter running full power. 10 degrees Celsius, 18 degrees Fahrenheit. So Lewis's 20-degree number is about on track for that. Now, other manufacturers will have different results or different specs. So absolutely 100% of the time refer to your manufacturer. Don't just say, well, Jeff said it should be 10 degrees. Why is it only, why am I, talk to your manufacturer for sure. John mentions tube transmitters are hotter. And that is, yeah, that is quite true. Uh, so let's see. Chris argued that dust gets onto heat sinks and fan blades, lowering the efficiency. 100%. I did a paper on cooling technology not too many years ago. Well, I mean, these days, 20 years ago is not too many, but one of the things that I covered was the fact that dust on a heat sink does significantly lower efficiency of the cooling. So for any air cooled system, the cleaner it comes back to, like I've said forever, three things: keep it cool, keep it clean, and keep it well grounded. And if you can do those three things, you will save yourself a whole lot of grief. Um, Lewis, I'm going to hit the unmute button. I'm just keeping an eye on the time. We're doing all right so far. Uh, there you are. And Lewis, you're, if I'm not mistaken, down in Utah. But so, question on that. So you said you're seeing about 20 degrees, and I say that seems to be about right. So it looks like you're doing okay. I guess that wasn't a question, but yeah. Any other thoughts on that, either from Lewis or Shane?
Nope, I think you pretty much covered it. That's keep it cool, keep it clean, keep it well grounded.
To see if I could probably make about 90% of my presentations, just put those 3 slides up on the screen, say, okay, that's done. Let's go have coffee.
Yeah.
Uh,
I did have, back to an earlier topic, I did have one quick thing about, I was mentioning earlier, the sizing of a system and whether you can size a system too large.
right. So back to that, and I kind of got sidetracked, which happens a lot.
Squirrel.
Yes, if you have a closed loop system and your AC unit is large enough that it doesn't cycle fairly frequently, and I forget what the optimal cycle rate is. I want to say 50 to 75%, but I'm throwing a dart again. So if anybody knows more than I do, which is almost everybody, reach out and speak on that. But if you're not cycling it often enough, you're not pulling the humidity from the air, and you can run into a condensation problem. And surprisingly, transmitters don't like to be wet.
So I actually ran into this once with an outdoor rack that had its own little cooler on it, right? It was extremely humid outside. The thing was, that little cooler was apparently oversized for that rack, and it was short cycling. But as soon as I opened that rack, everything instantly got a layer of condensation on it. I was like, oh, that's not good.
Yeah, yeah. And that happens a lot. It's the same as like when you get out of your car on a hot day in Houston, your glasses fog up. The exact same concept, almost. So you do have to pay attention to that. Elijah had asked, are liquid cooled systems much more expensive? Talk to different manufacturers. If you're below the 20 kilowatt power level, it's a hard sell, but typically it's a 10 to 15 to 20% difference depending on the manufacturer and the product you're specifically looking at. So, I'm not going to quote stuff on a webinar, but yeah, definitely something to pay attention to. And that's where we get this whole conversation, because everything is is situational. I've used that word so much, but like, so where Elijah is down in the Mississippi Delta, where a cool day is going to be 75, 80 degrees, then at high power levels, liquid cooling starts to make quite a bit of sense. If you're in the desert where it's a lot drier, but air temperatures can routinely get well up above 110 degrees, then that's a caveat about the not being able to cool lower than ambient, and the overall lifespan reduction as a result. That comes into play. If you're in the upper Midwest, where you can cycle outside air for 8 months of the year in a properly designed system, like on the screen, and again, not to blow my own horn for my highly technical Microsoft Paint drawing, but yeah, you could cycle outside air for 8 or 9 months of the year, use air conditioning to make up the other 2 or 3 months, and in the middle of winter, a lot of times you can end up shutting down the fans totally, close the system, and let the transmitter heat the room. Now, depending, as Shane said earlier, on TPO and operating mode, you may also find, and this is not really cooling, but related, you'll find some cases you may need supplemental heat. Let's see, new questions. Separate liquid. So Jim mentioned separate liquid cooling systems can be signed for transmitter only with the redundancy and margin, and then the building can have an independent system and that is 100% true. Again, with the caveat that Shane had independent system for the humans. Coming back to what Shane had mentioned, you may or may not need to cool some of the air from the transmitter. You will always need to cool the the computers, your HD gear, your processors, transmitter controllers. So 100%, yeah, you can certainly do liquid for just the sister, the transmitter, and warm air for or cool air for the building. Shane, thoughts on that? And again, my liquid cooled experience is limited, so I'm relying on everybody else for this.
Nope, absolutely. And I've installed liquid cooled from, from various players, the various manufacturers, and yeah, they all have their everything is. I mean, whether it be air cooled, whether it be liquid cooled, you make a great point. As they say, your mileage may vary.
Yeah.
It really does get situational. I found one particular situation that where liquid cooled did make sense was at a mountaintop site where there was little control over the internal environment of the building. It was not going to be feasible to really air condition it. The support equipment, okay, it may have taken a little bit of hit in terms of its comfort, and its longevity. But getting the heat from the transmitter outside of the building using a liquid cooling loop in that particular application made a lot of sense. It also kept the transmitter itself a lot cleaner. So
Yeah. Yeah. And I mean, I had one in a really, really bad site in a southern state where they would have been better off probably investing $2,000 or $3,000 in fixing the site ventilation overall. But for their particular situation with they were running a 30 kilowatt TPO in a fairly warm environment anyway, liquid cooling was a perfectly logical alternative for them.
right. And
You know,
sometimes you are going to run into those situations where you just, for whatever reason, don't have control over the environment of the site. So
right. Yeah. Then Elijah's asking if Nautel's considering making a liquid cooled. Uh, and yeah, no, not at the moment. The number of places where it does make sense, it'd be hard to justify the investment in creating the infrastructure for that. So, could we do it? 100%. Absolutely. We had a prototype for one built about 20 years ago. Could we do it in such a way that we'd sell enough to make the investment back? Probably not. And that's the challenge. Let's see. Joseph has a story. I probably should, you know me, I don't pre check anything. So y'all can send me stuff. It's getting read verbatim, no matter how bad it is. Had an Autel FM 3 kilowatt on winter when it was -10, got an over power alarm, 105%. Found the room was at 40 Fahrenheit, causing the transmitter to be more efficient. Forgot to turn on the wall heaters. And that is 100% true. The colder stuff gets, the better, if you could have got it down now. Granted, we have theoretically a 32 Fahrenheit, 0 degrees Celsius minimum. As I mentioned, the software has proven that if you get below 0 degrees Fahrenheit, that can be an issue. And condensation is always a concern. But yeah, lower temperature stuff does tend to run a little more efficiently. So that's also a point.
well, and the other interesting thing was, at least with some of the older designs, like exciters and STLs and so on, they did not like high or low temperatures either, because their PLLs would unlock and suddenly, boop, they would mute, and you had no signal anymore.
Yeah. And William mentions in here, to going back to liquid, sometimes liquid cooling is the right answer, sometimes not. And as I said, situational. It's not something that you can say we're going to do this at this power level for every single site, period. You've got to look at each situation on its merits and make the call from there. Now, air or liquid, if you don't cool it well enough, things get burny pretty fast. And some of y'all will notice that is one of our 50 kilowatt transmitters. And that thing to the right is another door that's open, but it had a filter failure. A lot of filter failures. The two primary causes in electronics in general of failures are loose connections or heat. Now, obviously lightning factors in there quite a bit. You throw enough voltage at something, it doesn't matter how well cooled it is, things going to stop happening, which comes back to my original: cool, clean, and well grounded. If you do all three, things get a whole lot better. By the way, clean the air filters. This is a prime example. This was a well air conditioned site, and not sure if Mike's in the audience at the moment. This is one of his. But but those filters, I think they got swapped out every 2 years. The room was sealed, positively pressured, air conditioned, everything was perfect. So, but again, pay attention to the details on that stuff. It's like your car. You drop the 30 or 40 or 50, I guess 100 and some odd nowadays with synthetics, but you drop the money in the regular oil changes so you don't drop a whole pile more money on swapping out the engine every 5 or 6 years. All right. Cool, clean transmitter sites make for happy transmitters. Happy transmitters make for happy engineers. Happy engineers make for, well, happy engineers don't make for happy management, but when management doesn't have to pay big old repair bills, things get a whole lot happier. So, Shane, any closing thoughts since you're, as I said, kind of became my unofficial guest for today? Thank you for that, by the way.
Oh, happy to do it. You never know what you're going to get when you give me a mic.
Your check's in the mail.
No, this has been a great session, and your 3 points can't be stated enough. Keep it cool, keep it clean, keep it grounded. So yeah.
By the way, anybody interested in the techniques, I put links up for these two. That article I mentioned by John Marcon in Radio World. That article does a really good job of providing the math behind figuring out your building cooling over and above the transmitter aspect that I showed several slides back. The International Rectifier Tech Note talks a lot about the different types of heating, because there's convection, radiation, and conduction, and it's important because I think it's convection. Might be conduction, one of the two, but the kind that applies specifically to both air and liquid cooling is the one that's hardest to quantify. So that techno gives you, if you want to hit the math on that, then absolutely, it is really, really fascinating. Now, let's see. Preventative maintenance, clean filters, clean sinks, heat sinks, clean blowout supplies. Yep, absolutely. 100%. Good comment there, Maurice. So one other note, final housekeeping note before everybody heads out. Conduction, cast iron skillet handle gets hot after you've had the gas on long enough. Yes, 100%. Oh, by the way, side note, I do a pile of cooking. My cast iron, I've got silicone slide-on handles for all my cast iron that you can, I just keep them in a drawer whenever I'm cooking with the cast iron. First thing I do is slide one of those on so you can pick the pot up without burning your hand, because I'm here to tell you, you will forget and it hurts. Anyway, so final housekeeping note, do not please forget to fill out the survey after the webinar closes. We live and die by those. There's only a few questions. If you want to put a suggestion for a future topic, that's awesome. This came from one of those suggestions, this whole session. So, we do read all of those. I think Ed may have gotten a little creative with the categories in the survey. So, maybe he might have toned it down too, because he's a little more careful about what he puts out in the public than I am. But, there you go. Have fun with it. If he did put the original in, you'll get a chuckle. So I did anyway. So there you go. Obvious link to the usual suspects when it comes to you get a raise. We'll give you a 10. Yeah, no, I get a raise. Yeah, double nothing is still nothing. But these are a labor of love, if you will, other duties as assigned. Anyway, so this will be archived. As I mentioned, you'll be able to find it on our YouTube channel or through the webinar link on our website. All the other TTTs, and as I said, this is episode 101. Hard to believe we've done that many of these. And thank you all for see a couple of repeat attenders. So that's really cool to see. But folks, on that note, we're 5 minutes past the top of the hour, so we kept it fairly close for a change. Shane, again, thank you very, very much for your time today. It's greatly appreciated, especially when you had no warning that this was going to happen.
Thank you, Jeff.
And folks, thank you all very much. Hopefully we'll see you next month. So for anybody based in the U.S., this is going to be especially relevant because we are talking EAS, well, not EAS, but IT security, and we'll be talking about it in relation to the FCC EAS rule, because that's going to apply to a whole lot more than your NDEC or your DASDEC. So, be sure to tune in for that. I don't know the date just yet. It'll depend. I have to sit down and look at my August travel schedule whenever I'm sitting still. Whatever Tuesday I'm parked in August, that's when we'll do it. So keep your eyes peeled for that. Any suggestions for September, October, November, etc., shoot them at us in the survey. Awesome. Thank you very much, folks. We'll see you next time. Bye now.